In this chapter, we are going to learn about ionic and covalent compounds. So far, we have learned about the atom and we have learned about the subatomic particles. Now, we are going to advance a step, and from the elemental form of atoms, where they are by themselves, we are going to now convert them into compounds. Compounds where you have two or more separate elements combined chemically to form a new compound with totally different physical and chemical properties. Now, whenever two different elements combine, they are going to form a chemical bond. A chemical bond is the force of attraction between any two atoms in a compound. And this force of attraction overcomes the repulsion of the positively charged nuclei of the two atoms participating in the bond. What does that mean? Well, the why would the two atoms come together first of all and form a bond? Clearly they both have nucleus and both of them have positive charge in the nucleus because of protons and also the electrons. While the protons in the nucleus of the two atoms repel each other, the electrons you would also expect to repel each other. So what brings them closer? Ultimately, it's the attraction of the electrons on one atom to the nucleus of the other atom where there are protons. Similarly, that second atom's electrons are attracted to the positively charged nucleus of the first atom. And so a chemical bond forms. Chemical bond forms, making them more stable than they originally were, which is why it forms in the first place. But it's not as simple. It's not just some attraction between all the electrons in one atom to the protons of the other atom. It rather involves valence electrons. What are valence electrons? Go to chapter 2 videos where we discuss valence electrons. Valence electrons are the outermost electrons. When you write the electron configuration, the outermost or the valence electrons are the electrons in the largest value of n for the main shell or the shell in which electrons are found. So, in order to make writing chemical bonds easier, a scientist at the beginning of the 20th century came up with his symbols named after him, the Lewis symbols. And in his symbols, what he did was he had the chemical symbol of the element, whatever is on the periodic table, surrounded by valence electrons only. Why just valence? Because those are the electrons which are involved in making a chemical bond. They are involved in a chemical reaction. And also, there would not be a situation where there would be less space than needed because the valence electrons will never go above 8. And as an exercise, you can try to write the electron configuration of any element on the periodic table and count the valence electrons. Whether it's just a few electrons or a lot of electrons, the total valence electrons will never exceed 8. Hence, at most you have 8 dots for 8 electrons around an atom. What does that look like? Well, you can start at any side on the symbol of the element and start making a dot on that side, but you can only have one dot per side. And then you move on to the next side until you cover all the 4 sides. Once all 4 sides are covered, then if you need to place more electrons because there are more valence electrons, more than 4, then you would start placing second dot on one side. At most you need 8 dots, and so at most you would have 2 dots per side. Here are the Lewis symbols of some of the elements, the representative elements, that does not include the transition metals. In group 1a you only have one valence electron and it's shown on the left here. You might have as well placed it on the right, up or down. Beryllium and other group 2a elements have 2 valence electrons shown here, and you may have placed them on any side, but as long as you place them on their own side, one per side, that's fine. Here you have 3 valence, then 4 valence. Now all the 4 sides are occupied with 1 electron here. Then we come back and place the other electron on a given side, as you see. Then all the way on the end, if you notice, these elements except for helium, the noble gases have 8 valence electrons, which each side occupied with 2 electrons per side. So this is how we make Lewis symbols. And with Lewis symbols, it will become very easy for us to depict ionic bonding and covalent bonding, which we will discuss in the next video.